Potential and kinetic energy test. Number 1, kinetic energy is A, stored energy, B, energy of motion, C, heat energy. Number 2, potential energy is A, stored energy, B, energy of motion, or C, heat energy. Classify the following statements as either potential or kinetic energy. Use a P for potential and a K for kinetic. Number 3, a car driving at 60 miles per hour. Number 4, the wind blowing through the tree branches. Number 5, a runner at the starting line of a race. Number 6, a soccer ball being kicked. Number 7, a cat sleeping. Number 8, a ball on the top of a hill ready to roll down. Number 9, a swimmer doing the backstroke. Number 10, a bow with an arrow pulled back. Number 11, one way that potential and kinetic energy are similar is that A, one is moving and the other is not. B, one is involved with water and the other is not. C, they are both involved in everyday life. D, they both store energy. Number 12, one way that potential energy is different than kinetic is A, potential energy is the energy of moving things and kinetic energy is not moving. B, potential energy is stored energy and kinetic is not stored. C, potential energy is slow and kinetic is fast. D, there are no differences. Use the picture below to answer questions 13 and 14. Number 13. At what point would the roller coaster have the most potential and the least kinetic energy? A, point W, B, point X, C, point Y, D, point Z. Number 14. At what point would the roller coaster have the most kinetic and the least potential energy? A, point W, B, point X, C, point Y, D, point Z. Use the diagram below to answer questions 15 and 16. Number 15. At which point or points does the swing have the most potential and the least kinetic energy? Choice A, 1 and 2. Choice B, 2 and 3. Choice C, only 2. Choice D, 1 and 4. Number 16. At which point or points does the swing have the most kinetic and least potential energy? A, points 1 and 2. B, points 2 and 4. C, only point 2, or D, points 1 and 4. Number 17. Students conducted an experiment by stretching the same rubber band to various lengths, releasing it, and measure how far it traveled. In the chart, the length the rubber band was stretched was 10 centimeters, 25 centimeters, and 50 centimeters. The distance it traveled was 50 centimeters, 80 centimeters, and 120 centimeters. Based on the chart, what conclusion can be drawn? A, the more mass that a rubber band has, the more difficult it is to move. B, the shorter the length of a rubber band, the less energy can be stored in it. C, the more potential energy put into a rubber band, the more kinetic energy released. D, the farther a rubber band travels, the less it can be stretched later. Number 18. Students are investigating changes from potential energy to kinetic energy by rolling a marble down a ramp made by propping up a plastic ruler on a book and letting it roll down. Which of the following will change the potential energy the marble starts with? A, switching the plastic ruler with a wooden one. B, adding more books beneath the ruler. C, pushing the marble down the ramp. Or D, replace the marble with a rock. Number 19. A truck is parked at the bottom of a hill. It moves from the bottom of a hill and parks at the top. Compared to when it was parked at the bottom of the hill at its new position, the truck now has A, more potential energy, B, more kinetic energy, C, less potential energy, D, less kinetic energy. Number 20, 4 students were asked to classify the activities of people in the picture below as examples of either potential or kinetic. Which student correctly classifies the activities? Student 1 says, which is choice F, the girl swimming laps is potential energy, the boy on the diving board is kinetic energy, the girl hitting the volleyball has potential energy, and the boy holding the volleyball has kinetic energy. Student 2, which is answer choice G, says the girl swimming laps is potential energy, the boy on the diving board is potential energy, the girl hitting the volleyball is kinetic energy, and the boy holding the volleyball is kinetic energy. Student 3, which is choice H, says the girl swimming laps is kinetic energy. The boy on the diving board is kinetic energy. The girl hitting the volleyball is potential energy. And the boy holding the volleyball is potential energy. Student 4, answer choice J, says girl swimming laps is kinetic energy. The boy on the diving board is potential energy. The girl hitting the volleyball is kinetic energy. And the boy holding the volleyball is potential energy. Number 21. A bicycle rider is traveling up a hill. When the rider reaches the top of the hill, she stops to rest. Then she travels down the hill. The diagram shows the rider in 3 different positions. Which of these correctly describes the potential and the kinetic energy of the bicycle rider? A. When the rider is at the top of the hill, her potential energy is the greatest and her kinetic energy is the least. B. As the rider moves up the hill, her kinetic energy increases and her potential energy decreases. C. When the rider goes down the hill, her potential energy increases and her kinetic energy decreases. And letter D. As the rider reaches the bottom of the hill, her kinetic energy and her potential energy decrease. Extra credit. What's the name of the pneumonia-like virus that is sweeping across China?